Hey everybody, I'm just out here checking on my goats. You can see them in the background there. And I also wanted to introduce this week's at-home experiment that you're going to be doing, looking at something called Fermi Problems. Enrico Fermi was a scientist who was famous for asking questions about estimating things that it was very difficult to know off the top of your head what the answers were, and sometimes the questions he asked were pretty outlandish, but you can figure out what the answer is just by doing some simple calculations and thinking about things that you need to estimate to figure out the answer. So you're going to be doing an at-home activity where you're counting the number of grains of rice in a jar or beans in a jar, but I wanted to talk a little bit about Fermi Problems. So I'm out here in my goat pasture. Here are the goats. This is Agnes, the pregnant one, and the other ones are not named at the moment because they're just born a year ago and we haven't decided whether or not we're going to keep them. But Agnes is their mama and she's pregnant and ready to have another baby. But I'm out here looking at this pasture grass and thinking about how my goats eat this grass, and I'm often wondering about how much grass is out here and how on earth do we turn that into goats. And so a Fermi problem that we can ask is, well, what's the mass of grass in this field? Now there are a couple of ways that we can figure out how much grass is in this field, and one is to just grab a handful of it and start counting, and if I count up the number of blades of grass, I could eventually figure out how much grass is in this field. Of course, that would be very difficult to do, so a little bit easier thing to do would be to collect up a well-measured piece of grass and figure out how much grass there happens to be. So if I do, take a collection of the grass, I can just go down here and draw a box that's, say, 6 inches on a side, and I can pull out all the grass in here and try to get an estimate of how much that grass weighs. If I think about that, think about how much that weighs. I could go get a scale and figure that out, or I could just kind of estimate that probably weighs, what do you think? Maybe 100 grams, something like that. It's probably 100 grams of grass. And so that lets me know that I pulled 100 grams of grass out of a 6 by 6 inch square. So 100 grams out of a 6 by 6 inch square, of course, looking around at this field behind me, I'd have to figure out how many square inches are in that field. But that's something I can do pretty easily by just looking at, these fence posts are 10 feet apart. And so I can start to count them up. I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's about 12 on two sides. And then 1, 2, 3, 4, 5, 6 on the other. So I've got 60 feet by 120 feet. And if I multiply that by 12 inches by 12 inches, that'll tell me the number of square inches in here. And then if I know the number of square inches and I know how many grams per square inch of grass, I can calculate how much weight of grass I can pull off of this field. So let's go ahead and remember those numbers there. I've got about 120 feet by 60 feet. I'm getting 100 grams of grass per every 6 square inches, or I should say a 6 by 6 square, and we'll see if we can figure that out. So we're going to go in and do that little problem here in just a second and see what answer we get. Okay, so let's go ahead and write down our data here. We measured that there are 10 grams of grass in every 6 by 6 inch spot on that lawn, on that pasture. And the pasture was, we estimated 60 feet by 120 feet. Now we need those in inches, so I'm going to multiply that by 12 and multiply that by 12. So that'll give me 72 inches long, 720 inches long, and 1440 inches long. And if I multiply those two numbers together, I get 720 times 1440 40, and that's equal to 1,036,800 square inches. And let's just call that a million, just to make the math easier. Square inches. Okay. And if we look at our mass, we've got 10 grams per 6 by 6 inch area, which is 10 divided by 36, which gives us about 0.3, 0.28, 0.3 grams per square inch. So now all I have to do is multiply this number by this number to get the total number of grams in that entire field. And so I take 1 million and I multiply that by 0.3, and that gets me 300,000 grams. And we know that 1 kilogram is equal to 1,000 grams. So if I divide those two numbers, I get 300,000 grams divided by 1,000 grams per kilogram, and that gives me 300 kilograms of grass. All right, so according to my calculations, I can get about 300 kilograms of wet hay off of that pasture about once a week. And the goats are pretty much keeping it eaten down. So that means 300 kilograms of hay is going into a goat every week. But you can tell looking at those goats that I'm not getting 300 kilograms of goat per week. Most of that has got to be pooped out, and that's where all that mass is going. But we're going to talk about conservation of mass later. But this gives you an idea of how Fermi Problems work. You've got one to do this week on your own, and you're going to be watching some demonstrations by Professor Ron Galley for Newton's laws, and I will check in with you later.